Okay, we carry on with the next question. It's similar to what we have just done earlier. So what we have here is this. Part A is to express in the completed square form as indicated in the question here. So what I do here is I'll say x squared minus x minus 3 in the completed square form. The x, the square, the minus, divide by 2, you get negative half. You square negative 1 quarter, you copy a negative 3. So here what I get is negative half square minus 13 over 4. It is advisable to leave this part here as an improper fraction. Now, in part B, we need to solve the equation. So do take note that this is equivalent to this x squared minus x minus 3. Hence, first I write down x squared minus x minus 3 equals to 0. So I use the equivalence is x minus half square minus 13 over 4 is equals to 0. Same thing, please do not go and expand the x minus half square. What we should do instead when we have the completed square form is to plus 13 over 4 on both sides of the equation. Now, okay, 13 over 4, when you square root, it doesn't come out to be a nice number. It's not an integer value. So what I can do here is this. I can say that when I square root both sides of my equation, x minus half is positive 13 over 4, or x minus half is equal to negative square root of 13 over 4. So, if I have done that, what I can do now is I use my calculator. Please do try to use your calculator together with me, okay, to see if you are able to get the same values. So, what happens here is this. What I can get here is I square root 13 over 4 plus half. My value here should be 2.30. Similarly, if I solve, here the value should be negative 1.30. Do let me know in class if you have issues with getting these two values, but if not, do try to ensure that you're able to do this. Similarly, for slide 14 itself, I will not go through slide 14, but you're invited to try on ClassKit itself. If everything works out, you should be able to get 1.56 and negative 2.56 for part B. Okay, I move on to slide number 15. Using completing a square method, explain why the equation has no real roots. Some of you may have already studied ahead, and then you already know the idea of the determinant itself, and then determinant is less than 0, but that is something that I leave for additional mathematics. In eMath, what they want here is to use completing a square method to explain why the equation has no real roots. What I'll do here is this. I start with x squared plus 5x plus 7 is equal to 0. I will do completing a square, x the square, the minus. So here is plus 5 over 2, 25 over 4, plus 7 is equal to 0. I simplify my left-hand side. What I get will be negative 25 over 4, okay, plus 7 is 3/4. So I have a plus 3/4 here is equals to 0. Now, if I were to attempt to solve this, what I will do is x plus 5 over 2 squared is equals to negative 3/4. So, normally, when we want to solve, what we'll do is we'll square root the left-hand side and you square root the right-hand side. If you haven't figured it out by now, give it a shot, okay? What happens, okay, when you square root negative 3 over 4? Your calculator will tell you that this is actually an error, okay? It's an error because you are not able to square root a negative number yet, okay? Eventually, you'll learn this concept of imaginary numbers, but for the time being, right, you are not able to square root a negative value. So in this case, what I can actually state here is this. The square root of negative 3/4 has no real roots. Okay, so you're just not able to do it. It's an error. Then hence, okay, the equation x squared plus 5x plus 7 is equal to 0 has no real roots. And And this is it for 1.1. So please refer to Google Classroom as well for the homework questions which are to be submitted on foolscap paper. Thank you.